Hello, Assalamu alaikum. Welcome to my channel Civil Network. Today in this video we will discuss about the design of transverse reinforcement for special moment resisting frame columns and also for the boundary elements of special structural walls. Here you can see my website civilabout.com. In this website I have written an article on this topic, and also I have developed a calculation sheet for the design of the transverse reinforcement. Here in this website civilabout.com, I am working on a project to develop some tools which are required for the design of the special moment resisting frames. As you can see in here that I have included some of the tools already, like to determine the joint shear, and for the strong column and weak beam requirement, to design the transverse rebar as per the probable moment for beams, and the transverse rebar for column and boundary element for structural walls. In the future I will also try to include some videos regarding these other tools also. Please subscribe to my channel and hit the like button if you like this video, and stay connected with us. So today I have divided this video into two parts. In the first part of this video I will discuss about the design criteria and design provisions which are mentioned in the code regarding the design of the transverse reinforcement for the special structures. And in the second part of this video we will design transverse reinforcement of a column using the analysis result from our sample model in ETABS and our calculation sheet. Let's go to our first part of this video, where we will discuss about the code provisions and design steps required to design the transverse reinforcement for RCC columns and boundary elements of structural walls. Here I will put down the link of this article and calculation sheet in the video description. Here at the end of this article I have mentioned the code references and books which I have followed to write this article and develop the calculation sheet. Here I have included two codes in this article and the calculation sheet. First one is the ACI 31819 code, and the second one is the BNBC 2020. You know that the BNBC 2020 is actually based on the ACI 31808 code, as the ACI 31819 is the more upgrade version of the ACI code. There are some difference in some aspects which I have mentioned in this article. Also I have provided two options for the designers. They can design as per their requirements and the preferences. So let's jump into the detailed overview of the code provisions requirements. For the design of the transverse reinforcement for RCC columns, mainly we have to follow three steps. The first step is that we have to determine the length of L0. Here L0 is the length of the anticipated plastic hinge region where the flexural yielding is likely to occur. Here in the section details you will see that these two regions from the joint face is termed as L0, and here the spacing of the transverse reinforcement in this region is termed as S0. In the first step, to determine the length of L0, we have to consider three parameters. The first parameter is that the maximum cross-section dimension of the column. The second parameter is the 1/6 of the clear span of the column, and the other parameter is 18 inches. Among these three values we have to take the most large values for L0. After determining the L0, we can go to the second step, where we will determine the spacing and area of hoops. The spacing S0 is the maximum allowable vertical spacing of transverse reinforcement along the length L0, which I have shown earlier in our section details. You can see that the vertical spacing of transverse reinforcement along the length L0 is termed as S0. So to determine the value of S0, we will also have to consider some parameters. The first parameter is the 1/4 of the minimum dimension of the column. The second one is the 6 times the diameter of the smallest longitudinal bar if the bar grade is 60, and 5 times the diameter of the bar if the bar grade is 80. And the other parameter is 6 inches. For another parameter, we have to determine the value of S0 using this equation. In this equation, the value of Hx is the term represents the maximum centerline to centerline spacing xi between laterally supported longitudinal bars. Which means if we see this cross section of column, here the value of xi is the distance in between the laterally supported longitudinal bars. As these two bars are laterally supported, we can take the value of xi, the distance between these two longitudinal bars. Among these values of xi, the maximum value will be considered as the value of hx. And as per the code, the value of hx shall not exceed 14 inches. The last parameter is the spacing we have to determine from the required area of transverse reinforcement, which is termed as ASH. In the code, there are mentioned 3 equations to determine the required transverse area of reinforcement in the region of L0. From that requirement, we have to determine the value of S0 using these 3 equations. And here I want to mention that the equation A and B, we have to consider this all the time, but whether we should consider equation C, it depends on a criteria, which is that the maximum axial force including the earthquake effect is greater than the 0.3 AG F prime C, or if the F prime C is greater than 10,000 psi. In between these two conditions, if any of this happens, we have to consider the equation C also. But this provision is only mentioned in the ACI 31819 code, not in the BNBC 2020 code. So if you design in BNBC 2020 code, you do not have to consider this equation. Here, if this case is triggered, there are some special detailing requirement for the transverse reinforcement. Here in this note, I have written those requirements. The first requirement is that every longitudinal bar or bundle placed around the perimeter of the column core must be laterally supported. That means here you can see that the cross ties are placed alternate longitudinal bars, but if that case is triggered, we have to provide these cross ties in every longitudinal bars. And the second requirement is that this lateral support must come from either a corner of a hook or a properly anchored seismic hook. That means that all the cross ties or the hoops has to be properly anchored or maintaining the seismic hook requirement. That means the angle of these hooks has to be 135 degree, not 90 degree. So in the both end, we have to provide 135 degree hooks. And the third requirement is that the maximum clear spacing between supported bars Hx must not exceed 8 inches. So the limit of Hx which was earlier 14 inches, is now 8 inches if this case is triggered. So the spacing of the longitudinal bars around the perimeter of the column cannot exceed the value 8 inches. In the third step, we have to determine the design shear force based on the probable moment ampere and design the transverse reinforcement to resist that shear force. To do this, first of all, we have to determine the maximum axial force using the load combinations, which includes the earthquake effect. From that axial force, we have to determine the corresponding probable moment. To get the probable moment value ampere using the axial force Pu, we have to generate the interaction diagram. There we have to consider the tensile stress as equal to the 1.25 times the yield strength of the reinforcement, and the strength reduction factor has to be equal to 1. So to generate the interaction diagram, I have developed another calculation sheet. If you go to here, the tools, and from here you will get a link for the interaction diagram. Here, to generate the interaction diagram, you have to input the design parameters and revert details of the column, and from this calculation sheet we will get our probable moment. I will discuss about this more in our design example. After we get the probable moment from the interaction diagram, we will calculate the design shear force Vu, and after that we will calculate the required spacing and the required transverse reinforcement to resist that design shear force. So these are the 3 steps which are required to design the transverse reinforcement for special moment resisting frame columns. I have considered all these provisions in my calculation sheet. We will discuss about that in our design example. Here you will see that in this article I have also included the design requirement for the transverse reinforcement design of boundary elements of special structural walls. Here some parameters are mentioned for the spacing of the transverse reinforcement. The first parameter is that the 1/3 of the minimum dimension of the boundary element. The second parameter is 6 times the diameter of the smallest longitudinal bar if the bar grade is 60, and if the bar grade is 80, 5 times the smallest longitudinal bar. Other parameter is 6 inches, and similar to the column, we have to follow this equation for boundary element of wall also. And you can see that for the requirement of ASH, it is only mentioned the equation A and B, but equation C is not here. It is only for column, not for walls. So therefore we do not have to consider the equation C for the structural walls. So our first part of the video is completed. Now we'll go to our second part of the video.